Hello, this is AJ, and this tutorial will go over randomly positioning and sizing rooms in a scene which could be used for a dungeon or possibly a cave system. There's a link in the description which references a video that this algorithm is based on. I would recommend watching that video before watching this one. Ready? Oh yeah, the source code for this is in the description of the video as well. In my example, there are two scenes. One that represents the algorithm from the reference video, Demo Rigid Body, which has been included for completeness, and the other scene is my update, Demo Rec 2. If we run Demo Rigid Body, you'll see it randomly places the rooms and connects them using Prim's algorithm. There's a button which is used to regenerate the rooms. Now let's look at Demo Rec 2. As you can see, it does the same thing, but it has a few advantages. Let's go over the code for that scene. Here's the callback for the button. It clears the room bounding boxes array, which is an array of rect2s. Then it calls the makeRooms function. From there, it grabs the room position, center of each rectangle, and calculates Prim's algorithm, minimum spanning tree. The heavy lifting is done in the makeRooms function, so let's focus our attention there. Okay, you'll notice that the beginning is just like the reference video, creating a number of rooms and placing the rooms next to each other, assigning each room a random width and height. From there, we have a while loop, which continues if the move boolean is set to true and iterations is less than max iterations, which is set to 100. Inside this loop, it iterates through the rooms in the room's temp array and creates the source rectangle, which is rect A. Then it iterates through all the rooms added after the source room and creates the target rectangle, which is rect B. From there, it checks if the rectangles intersect each other. And if they do, then it sets the move boolean to true, which will cause this whole thing to happen again, and calculates the direction from source to target rectangles and normalizes it, which simply sets the x and y coordinates between 0 and 1 respectively. Then it calculates the overlap between the two rectangles. From there, it calculates the push variable, which is the direction times the overlap divided by 2. The 2 is just a coefficient. You can use that to make the rooms closer together or further apart. The source room position, room A, is then moved by the push amount, and the target room position is moved by negative the push amount. In this way, it works a lot like Rigid Body 2Ds, just blasting the rooms apart. After the loop is completed, some rooms are cold, i.e. removed. The numRooms variable is set to 50, and col is set to 0.5, so we expect to have approximately 25 rooms. It then adds the rectangles to the bounding box array, which is used in the draw function. And that's pretty much it. So the difference from the original tutorial is that the rooms aren't a Rigid Body 2D. The advantages to this are no settling time. When the function completes, then all the rooms are settled. Also, this doesn't require the rooms to be in the scene tree. And as a side for that, that means it can be run on a separate thread. Now, I'm not saying the original algorithm is bad. It just didn't fit my use case, so I modified it a little bit. Let me know what you think. Thanks.